here's another problem that I could use a trig substitution for, but you should be careful about these because some of these problems, although you could use trig substitution, there might be something easier or more efficient. So something to look for is, can you use regular U substitution? And the answer to that question on this problem is yes. So I have here the integral of x over the square root of x squared plus 4 dx. And I'm going to write this. I'm going to put in this little bitty step just because I like to see this step. One thing you could do when you have fractions is think about separating the numerator from the denominator. So I can say that's 1 over the square root of x squared plus 4 times x over 1 dx. So I wrote it as the multiplication of two fractions. And that's what the original problem equals right there. If I were to multiply these two fractions, I'd get that back again. And I'm going to put in one more little step here. So the integral of 1 over this square root sign, I'm going to write it as an exponent. So I'll have 1 over x squared plus 4, that's to the 1/2 power, and then x dx. And if you look carefully at this problem and think about U substitution, it's a great problem for U substitution. U is x squared plus 4, and then the derivative of U with respect to x, du over dx would be 2x. So du would be 2x dx. If I solve this for x dx, since that's what I have in the problem right here, I can say that du over 2 equals x dx. And then I could write that as 1/2 du is x dx. Either way, I could have maybe done that here. All right, I'm going to separate this thinking part from this working the problem out. The integral of 1 over u to the 1/2, and then x dx is 1/2 du. This 1/2 that's in front of the du, that I'm going to factor it out pull it out on the other side, the integral sign. So 1/2, remember you can do that with coefficients, but not variables. So 1/2 times the integral of 1 over u to the 1/2 du. 1 over u to the 1/2 du. And I like to think of this as u to the minus 1/2, so I'm going to write it that way. U to the negative 1/2 du. And when I'm doing the antiderivative, it helps me to see it written like that rather than try to do the antiderivative in my head from here. So here, I'm ready to do the antiderivative. Add 1 to negative 1/2. So this will be u negative 1/2 plus 1 is positive 1/2. And whenever I'm dealing with fractions, I will skip this little space because here, instead of dividing by 1/2, I'll say, well, you know what? I'm going to multiply by the reciprocal, which is 2 over 1. So there's my antiderivative. Don't forget plus c. Now I have 1/2 times 2 over 1. This right here gives me 1. 1 times u to the 1/2 is u to the 1/2. So u to the 1/2 plus c. And now I need to put x squared plus 4 back in the problem for u. So I'll use parentheses here. Open parentheses, x squared plus 4, close parentheses, that's to the 1/2 power, and plus c. So this problem, although I could have done trig substitution, and if I did trig substitution, I should get this exact same answer. So, although I could have done it that way, it really was just a U substitution problem. So that's something that you should watch for.